All right, today we are going to talk about section 9.4, graphs of quadratic functions. We're going to talk about looking at the graphs of quadratic functions and stating different characteristics of them. We've dealt with quadratic functions before. A lot of times we have dealt with them in that fashion. Today we're going to also talk about them written a little differently. In vertex form is another way where we can see them based on shifting the graph, similar to what we've been talking about the last couple of days. First off, what I'd like you guys to do is make sure you guys have your graphing calculator out. So if you need to, pause the video and get out your graphing calculator. And then make sure that you can type these equations into your calculator and check out what they look like on the graph. So pause the video and put those 4 equations into your calculator. When you do that, we can see that the blue one here would be the x squared. We talked about what that number in front, the 2, how it's going to make the graph go up quicker. Copy that properly. So the 2 is going to make that one go quicker. And then similarly down on the bottom, we're going to have this one go up quicker with the negative, or down quicker with the negative 2, and then with the negative 1/2, you're going to see that it gets wider. So we're going to talk about these different characteristics with these graphs. And there's lots of different characteristics that we can look at. We're going to look at the vertex, whether it has a maximum in, the line of symmetry, if it goes up or down, y-intercept, size of the curve, domain, and range. We're going to talk about a lot of these. If we look at the first one, just the parent graph of y equals x squared, what are some characteristics that we can see just by looking at this graph? The vertex being the point that it starts on the graph. Where does it start? Right here. It's symmetric on each side of this point. The vertex of this one is at 0, 0. Because the graph is going up, we can actually answer that part right now. The direction of the curve is going up. That means that that point of 0, 0 is the lowest point on this graph. It doesn't get any lower than that. So the minimum value is when the y value is equal to 0. It's at the point of 0, 0. The line of symmetry, so we can see here that it's symmetric on either side, and it's on either side of the y-axis. So this is our line of symmetry. We can talk about what is the equation of that line, and that equation of the line is x equals 0. The y-intercept is the point at which it touches the y-axis, which also happens to be the origin. So the y-intercept is 0, 0. And then the size of the curve. We've talked about how the numbers outside right next to that x squared will help make it go up faster. So it'll be a little thinner, or it will spread it out to be a little wider. Well, we have no number out there, so this is just a normal curve. And then we have 2 things we need to answer here, the domain and the range. When we're talking about the domain, we're talking about the x values. And for the range, we're talking about the y values. So given this graph, looking at the x values, what are the possible x values? Well, the x-axis goes from left to right. So we're talking about the values that go from left to right. And as this curve continues on forever, it could actually be any value coming from the left, because this graph would go on forever. And then it will eventually, as it continues on forever, go to any value to the right. So the domain actually starts at negative infinity, because it could be anything as we go out far, far to the left. And it can go all the way out to infinity. So those are the domain values. That's the values that it could be. And as far as the range, we're talking about the y values. Well, what are the possible y values? There are no y values down here. It doesn't even start until 0. So the starting range values are 0, and then it will continue up forever. So it goes from 0 all the way up to infinity. Now we will answer these questions for other ones as we shift it or make it wider or thinner. Let's take a look at this next one. Why don't you go ahead and plug this one into your calculator and graph it, and then we will state the characteristics. And the next points down here are off of our graph, but we get the idea of the graph. So this is what our graph should look like of negative 3x squared. So let's talk about what are our important pieces of information here. So again, we could be answering what is the vertex here. So the vertex is, again, 0, 0, right here. And in this case, is this a maximum or a minimum value? It is a max value because it doesn't get any higher than this. And what is the max value since we're going on up or down? The y value is no more than 0. And then again, looking at the line of symmetry, this is where the graph is symmetric across that line. So that is a vertical line, which is x equals 0. And I wrote the the maximum value. And then for D, the direction of it, it clearly opens down. And then for E, the y-intercept, where does it touch the y-axis? Again, it's right there at the starting point of 0, 0. And then is this one a wider, thinner, or normal graph? Well, because of that number, it's going to shoot, well, down, but it's going to get thinner because it's going at a quicker pace because of that 3 in front. It's making each point get there a little quicker because it would actually been there on the normal graph. And out here, that was the x squared or the negative x squared. It's getting thinner. It's going at a quicker pace. Now we need to talk about the domain and the range. So what are the possible x values? Again, going across the x-axis, left to right, because it's going to go down and to the left forever. It's coming from that direction. It could start at negative infinity. And as it continues out this way forever, it could go all the way out to infinity. And then for the range, the possible y values, it starts all the way down here at negative infinity because the arrow's going forever. And it stops up here at 0. So it's going to go from negative infinity until 0. Okay, what I would like you to do next is type those two graphs into your calculator. And then we will compare what those two look like. Okay, after you type those two graphs in your calculator, we should get, compared to the original of y equals x squared, we should get these graphs. And this is going back to what we've talked about before, the x squared. And then the x minus 2, remember, because it's affecting the x, we have shifted the graph 2 units to the right. And here we have shifted the graph 4 units to the left. So we're still incorporating the shifting, the transformations that we've been talking about. But we're also going to be finding the different characteristics for this one. So what I would like you to do is type this one in. And I would like you to pause the video and attempt to answer the characteristics, the same ones that go back to the first page, the vertex, max, min value, line of symmetry, etc. Go ahead and pause the video and answer these questions, and then we will check our answers. Okay, when you type this in, your graph should look like this. So let's see, what are some characteristics? Here is the vertex of 3, 0. And it has a maximum value of y equals 0. The line of symmetry this time is over here. We go through as a vertical line through 3. So the axis of symmetry is x equals 3. Clearly the graph goes down. The y-intercept, it's where the point at which it touches the y-axis. This one might be a little bit hard to see, but what does it mean for it to touch the y-axis? That means that our x value is 0. So we could plug in 0 for x and solve. And when we do that, we get a value of negative 18. So the y-intercept is 0, negative 18. Because of this 2 in front, we know that the graph is thinner. And then we need to talk about the domain and the range. The domain, the x values, again, it's going left to right, and because it's going on forever, to the left, to the right, it could be from negative infinity to infinity. And the y values, it's starting down here and it's ending up here at 0 on the y-axis, so the range goes from negative infinity up to 0. And that concludes section 9.4.